So, remember when I told y'all that 90% of calculus is what? Y'all remember that? So how would you do some of these problems? Oh yeah, and this is the last section I'm going to cover in this unit. So make sure you get this homework done when I post it, because we're going to have a test on unit, I guess this is unit 3, isn't it? So we want to get to polar coordinates. I want to get to that before the semester's over. I just wrote some examples down. We're going to wrap around and go back to them. Now just look at those. You don't have to actually try them, because you're probably not going to be able to. But just look at them and tell me what you think. The first thing you would think about probably is factoring, and that's good. But whenever you see, and it doesn't fit any of the trig functions, the trig substitution that we just went over, because you don't see the square root, but they are rationals, right? And when you see rationals, you need to think, what do I do? Well, you could use long division if the degree of the denominator was smaller than the degree of the numerator, but that's not the case here. Of course, you could factor out an x up top, but the bottom is not factorable. You could factor x plus 2 quantity squared here, but that's not going to do you any good up there because it's x plus 1. Here it's x plus 2, x minus 2. Again, that's not going to do you any good. In other words, you hit a what? You hit a wall. Go ahead and use partial fractions. How many of you remember partial fractions? Mr. Silver, show us how to do partial fractions. Patrick Starfish, right? Anybody, seriously, does anybody in the classroom, I don't know about Skype, speak up. Anybody remember partial fractions?
Is it like distributing the terms to each one? Like splitting it up into multiple factors? Split it up into multiple factors, that's good, yes. Do you remember it? Vaguely? Yeah. Well, what you do is you factor it into its linear function, linear factors. All right, linear means x to the first power. Remember? Line, straight line. Okay. The reason I say this, and the reason I'm being like this about this, is because this is the number one thing in algebra that people can't stand. Or they forget the first. They forget if anything in anything in algebra that people like to forget is these things. And that's what students do. They learn it in what, algebra 1, algebra 2, or pre-calc. And then the first time they do, I'll be glad when I get through with this test I can forget this. And they do. And then they push it back in the back of their brain. All right? Subconsciously or consciously, I don't know which one it is, maybe both. But it gets put back there, and when you see it again, it's like, ugh. So we're gonna go over a review, and we're gonna do some problems, okay? And we'll come back to these as we progress, because, like I say, 90% is algebra. So you got something that looks like this. X over x plus 3 times x minus 3. Now, of course, this could be written, no, x minus 2. This could be written as, y'all see that? I got an eraser today. Let's see how long it lasts. Okay? So that could be what? X squared plus 1x minus 6. Is that what that is? It could be written like that too. X over x squared plus x minus 6. Either one of those. Now, this is to the first power, this is to the first power, and this is to the first power. So you've already went from a nonlinear to a what? Linear factors. So you're on your way right there. When you have linear factors, all you have to do is split them up, like Mr. Edwards says. Split them up, and that gives you x, I'm sorry. I don't understand these pens sometimes. A over the first one, x plus 3, plus b over x minus 2. Now you starting to remember a little bit? Yes or no? Okay. Now we're getting to the second biggest problem students have in calculus. They haven't been taught, or they had other things to do the day it was taught. How about that? I'll give the benefit of the doubt. The whole thing is, I think out of calculus, both calculuses, this is the number one thing that students shut down on in calculus. They do. So we're going to go over it. All right, and finish it. Let's see if you can at least do that. Clear the fraction, multiply both sides by the common denominator. Now all y'all should be able to do that. If you can't do that, then I'll go ahead and drop you from the class. How about that? Yeah, Hubert. Y'all see the Anderson campus on TV last night? No, yeah, y'all don't watch news. Y'all stay informed. The Michelin Man was out here yesterday. I didn't go down there. I was in my office. They were downstairs. They had a big Michelin partnership with Tri-County Tech yesterday. Multiply both sides through by what? X plus 3, x minus 2, Hubert. That's right. And you get x is equal to what? A times x minus 2 plus b times what? X plus 3. You're a little bit too loud, Miss Sheep. You need to bring it down a few notches so I can turn on my Bluetooth hearing aid and hear you. Speak up. Now, there's two ways to solve that equation. See what you can do with it. Staring at it is not a way to solve it. Patrick Starfish. Ooh. Did I tell you I bought the episodes for SpongeBob on my Fire Stick? I had to. My son. That was part of his pay for working on the farm, is buying the episodes. Each week he works on the farm, I buy him, I give him money, but I also buy him a season of SpongeBob. I get out pretty cheap. It's $15. That's pretty cheap. So I reference SpongeBob and characters on SpongeBob a lot. That's why. All right, Mr. Edwards, you remember how to solve it? Okay. Where do you remember? Let me ask you this, and I'm just asking for me. Where do you remember this from?
I thought we had homework as a calculus one.
You probably did go over an introduction or a review, depending on the teacher. And you didn't have me. Who did you have?
Marshall.
Okay, yeah. Yeah, he probably reviewed over it. But you don't remember how to solve it? Okay? Anybody else remember how to solve it? No, Hubert. Well, one way is to find out what will give you 0 on one of these. Remember, like signing out your domain? Okay, do that. What will give you 0 here? +2. So plug in +2 for x. Come on, y'all can do it. Y'all didn't do any math over the week, did you? It's like everybody's got a hangover. I'm having to give you black coffee, stick you in the cold shower. I had to do that with so many Marines. Of course, I didn't have to do it, but I had to do it for Marines at one. So if I make x equal to 2, then I'm going to get 2 is equal to a times 2 minus 2 plus b times what? What happens? That's not rhetorical. I'm asking you all to answer. This goes what? Out. Because that's 0 times 8, it goes out. So now you got 2 is equal to what? B times what? 5. And B is equal to 2/5. And of course, what do you do as a 2/5 now? I mean, no, you don't. I'm thinking of solve the system. Okay, now you found out B. Now what? How do you find out what A is? What will give you a 0 here? So -3, and that'll give us -3 is equal to A times -3 minus 2 plus B times -3 plus 3. That goes out. -3 is equal to A times what? -5. And A is equal to what? So now I can rewrite that as 3/5 over x plus 3 plus 2/5 over x minus 2. Now, why would I want to do that? Because if I was taking the integral of this, then now I can take, really? Oh, I wish I could figure out why There. Okay, did y'all see that? I had to go over here and get the eraser to work. All right, what is this? 3/5? 3/5 is A, right? And B is 2/5. And now, isn't this and this easier to work with than this? Because what the 2/5 comes out, you have dx over x. You can take the what? You can take the antiderivative. Most of the time, you're going to get a lot of natural logs in these answers. Okay? When do we integrate? We're just doing algebra right now. But what's u? X minus 2. What is du? Dx. So you have dx over x, which is the natural log of x, or u, which would be 2/5 natural log of x minus 2, 3/5 natural log of x plus 3. And that's your answer. So you've taken something that's pretty much yucky, and you use partial fractions to break it up into its linear fraction. And the reason you want it in linear is this. That's why you want it in linear, x to the first power. If you get an x to the first power, then that's easy to take the antiderivative, or the derivative, which then you take the antiderivative. Capiche? Thank you, Mr. Patel, for the interaction. The rest of y'all suck. All right, now do it the long way. That's one way to solve it. I'm waiting. Give y'all a minute to do it the long way. There's another way to solve it. It's the long way. And there's a reason I'm showing you both ways. I'm not showing you the long way just to aggravate you. I'm showing it to you for another reason. It's called equivalent or equal coefficients. So what could we do? Do y'all like need to go downstairs and get a Mountain Dew or something? That's what it is. Oh. How would you tell me how you solve for A and B? Well, wouldn't you have to distribute first? Because you got to get A, you got to get X. So your X is in the parentheses, right? If you want to find out what X is, you're going to have to get X isolated, right? So you're going to have to distribute it. You're on the right track. I'm going to put me a 1 in front of this X just so we're going to do equivalent coefficients. Combine like terms. I'll let y'all do that. Miss Sheep, you ever remember seeing this? Probably happens. Calc 1, my Calc 1 class, which some of y'all are in my Calc 1, some of them didn't have a clue. Which is normal, because like I said, the people push this back. And another thing is, sometimes the pre-cal teacher, or the algebra 2/3 teacher, or whatever high school you went to, usually waits till the end to do this, because it's the last thing they cover, and they don't have much time to go over it. Huh? Yeah. Now I'm going slow because, like I said, there's a lot of people that forget it. How about the Skype people? Any of y'all remember it? Like they gonna answer, they're going back to bed. All right, so 1x is equal to ax plus bx minus 2a plus 3b. And I'm going to shrink this down a little bit. Mr. Wizenhunt, you there? I'll just have to call somebody out. Make sure they can hear me. Can y'all hear me?
Yeah, I can hear you, Hubert.
Okay.
Yeah.
Mr. Wizenhunt, you there? I can always depend on Mr. Wizenhunt. Probably asleep. Make sure everybody can hear me. Okay, they can. Well, I can't ask my Calc 1 students because they had me, but
Hey, Hubert,
yes.
did you ever get it working in that other classroom? Remember you tried to do a presentation that one time, it didn't work. Did you ever figure out how to get that working?
Yeah, we're still working on it. They're going to get me a, what do you call these things that I don't like them? Tablet? What do you call them? Touch screen, huh?
Okay.
No, touch screen. It's not a laptop. It's a, huh? Yeah, something like that that I can use a screen, touch screen. They're going to get me one of those and see if that'll work. I really just want to use the document camera because I think students see that better. But try to tell an IT person that you need this instead of this. It's like telling an engineer that they're not right all the time.
Especially when it's more old school.
Huh?
Especially when it's more old school.
Oh yeah. But I don't think a document cam is well, I don't, but some people think it's old school, but I don't think the document cam has gone out yet because there's really no way to present what you're doing other than a document cam. You can present like I'm doing right now with a tablet, but it's not what the teacher's writing. It's a picture of what the teacher is writing, and I don't like that. But anyway, I done forgot what I was asking. Okay, so what can I do with the X here? Factor it out, Hubert. That's right, class. Y'all forgetting all y'all's algebra? Now, here's the part that you need to kind of, your box that you're thinking in, you need to not think out of the box, kind of expand your box. And I'm going to rewrite the left side as 1x to the first plus 0x to the 0 equals a plus b x to the first minus 2a plus 3b, and I'm just going to put that in parentheses, put a plus here, x to the 0. I'm going to take my handy dandy highlighter and I'm going to highlight this 1 here. I'm going to highlight that A plus B here. Why? Because they are both in front of the what? X. You see, they are both in front of the X. So technically, they are coefficients. They are equal coefficients. Now, if I had 2x is equal to 4x, then you would say the 2 is equal to 4. Of course, that's not true. But when you have a variable, you can have a plus b is equal to 1. Okay? And I'm going to take my handy dandy, and you might want to take your handy dandy highlighters out and use this in your notes so you won't forget it when you get home. So 0 is equal to what? That. Now, this is called, it's called equivalent coefficients or equal coefficients. That's what this is called. So you need to write that down, because in the next couple of examples, when you use partial fractions with a quadratic, you have to use this because you can't use the 0. The 0 shortcut is good usually with linears, because what's x squared? Anything x squared is going to be a positive, so you're not going to be able to get rid of, you're not going to be able to get 0 with a quadratic. Okay? So you have to have 2 methods. One method is a shortcut, which is the 0 property. The other method is equal coefficients. You can't pass this section without knowing both methods. All right, now solve it. You got 2 equations, 2 unknowns, right? Yes, Hubert. That's right, class. All right, everybody will have to have sugar and caffeine before y'all come to the next class when you talk Thursday. Now, what we're going to use, what do we use when we're trying to solve for 2 equations, 2 unknowns? Algebra people. Come on, y'all got to remember that. My Calc 1 students should remember it.
Substitution.
Substitution or elimination. Great. Somebody. So we've got 1 is equal to a plus b. I'm sorry. 1 is equal to a plus. Yeah, 1 is equal to a plus b. I was having a brain bubble there for a minute. You ever go to a stop sign and can't remember if you stopped or not? I just had one of those moments. Did I? A plus B. Or you call somebody and it rings for 3 or 4 times and you forget who you're calling. You ever done that? You will. 0 is equal to negative 2a plus 3b. I'm going to use elimination because I like elimination. Or we could use the matrix. You want to use the matrix? I don't think that y'all's brains already scrambled from break. If I do it, it'll probably liquefy you. I'll do it with matrix. All right, so I'm going to multiply the top by what? Negative 2, Hubert. That's right, class. Glad you could remember your elimination. So negative 2 times 1 is negative 2. Negative 2 times a is, I'm sorry, positive 2. So 2a. And 2 times b is 2b. Add them. That's 2 is equal to 0a plus what? 5b, Hubert. That's right, class. What happens to the a term? Goes out. Then you get b is equal to what? Does that check? Yep, we got 2 fifths before. Now, I'm going to redo define b. Now, of course, all you got to do now is back substitute b into the original equation and get it. But I'm going to do elimination with the other just to show you how to use eliminations. So I'm going to take this and I'm going to erase this. I'm going to erase this. And I'm going to use elimination just to refresh your memory. I'm going to multiply the top by negative 3. And that's going to give me negative 3 is equal to negative 3a minus what? You always add. That's negative 3 is equal to negative 5a. And what happens to the b term? Goes out, Hubert. That's right, class. Negative 5, negative 5. A is equal to what? That check? So that's how you're going to use a lot of solving systems of equations in this section. You're going to use a lot of zero property, and you're going to use a lot of the equivalent fractions. Capiche? Well, what if you have a quadratic? Well, you just are repeating, not a quadratic, but a repeating. So that's if you have linear functions, you just break them up into A and B. Everybody with me? Let me go back and show you what I'm talking about. Well, I got that too far. Well, this right here. Those are all what? Linear. So if you have all linear, you just use A and B. But what if you don't have all linear? If you don't have all linear, you just say cannot be done, right? Yes, Hubert. Well, before I do nonlinear, let's do repeating. 1 over yeah. 1 over x squared minus 4 times x minus 2. Okay, before I do it, I want you to write that out. I want you to use your shortcuts, which you shouldn't have forgotten, because we've been using them all semester. And write that out. Somebody out there this morning, they have shortcuts. Yep, they're going to follow you all the way to differential equations. Now what does that come out to be? 1 over what? x plus 2, x minus 2, and x minus 2, which can be written as 1 over x plus 2, x minus 2, what? Now, we still have linear functions. X to the 0, which, and then x to the first, x to the first. We've got linear factors, so we're still going to use a and b, but we've got a repeating factor, right? The way that you do repeating factors is always remember, when you're factoring out a common term with an exponent, you always use the least exponent, right? If you are finding the common something, common denominator, common whatever, you use the highest what? The highest exponent. And just so you remember, if I wanted to factor, if I have x to the third minus x squared, and I want to factor out something, what am I going to factor out? X squared, because it's the lowest what? Exponent. But if I want to find something in common, if I have 1 over x plus 1 over x cubed, what do I go with there? X cubed. So you got to work your way up to the highest exponent. You with me? All right. Just remember this, highest exponent. So what's the highest exponent with x minus 2 and x minus 2 quantity squared? 2. So you've got to work your way up. So when you have repeating factors, when you have repeating factors, you've got to build up. Write that down, build up. So I'm going to rewrite this as a over x plus 2, that's the one that's not repeating, plus b over x minus 2 to the first power, plus c over x minus 2 to the what? Second power. You see what I did? I built up to the highest exponent. So you need to remember that. You need to take your highlighter and you need to highlight this guy and then highlight this and make a note, build up. Now we're not going to do this one because one thing you're going to realize about these things is some of them are actually very what? Tedious. Because you're going to see some later that takes about a page just to do the algebra, because you've taken x minus 1 and multiplied it by x minus 1 quantity cubed, and that's a mess. So I'm just giving you this as an example of repeating. If you have something that has a square or a cube, so that was x minus 2 quantity cubed, it'd be d over x minus 2 quantity cubed. Okay? Now, what if you have a quadratic? And that the quadratic is pretty much the last one. So, 1, you've got all linears. And that way you use a plus b plus c, dot, dot, dot. And then 2, repeating. There we go. And we didn't even switch back to the yellow. We switched to, now how did I do that? Somebody tell me how I did that. And I haven't even used the purple or magenta. I'm glad I had training on this. Huh? No, I think it's mental collectively. I think I'm using H for sensitive perception. Repeating factors. And put under that highest exponent. Just kind of remember that if you have an x and x to the third, you got to build up to the x to the third because it's the highest exponent. And that's build up. The third thing is quadratics. And when we're dealing with quadratics, we have to use, instead of a plus b plus c, we've got to use a x plus b over so-and-so plus cx plus d over so-and-so. In other words, you've got to use that. All right, so you might want to write this down and put it somewhere where you can remember those are the three type problems that we're going to be looking at. And again, what are we doing? Nobody's ever going to walk up to you and ask you what this is, but the original equation is a big mess. And what do you do with a big mess of a problem? You break it down and break it into its parts. That's what we're teaching over and over and over and over. Nobody's ever going to walk up to you and ask you this. But they will ask you to break the problem up and solve it. X plus 1 over x squared minus 4 x squared plus 9. Now what do you notice, what do you notice about the denominator? 2 or 3 things. Okay, speak up. They're not repeating because the square has to be on the outside.
Oh yeah, but it's x plus 2 squared and then x plus 3 squared.
That's not a shortcut. There is no shortcut a squared plus b squared. Yeah, that's a common mistake. That's fine. That's common. And that's the reason I picked these two. It's common to think, oh, that's a shortcut. They're right down at the bottom. Not a shortcut. Neither one of them are. There is no a squared plus b squared. That would be shortcut number 4. And then you would have 5 and 6. You would have 6 shortcuts instead of 5. There is no such thing as a squared. There is no such thing as the sum of 2 squares. Okay? So that's one thing you notice, that it's not factorable. What else you notice? Both of them, the x is raised to the what? Second power, so they're not linear. They're quadratics. So we're going to have to break them up nonetheless. So break them up into, and you can't factor them, so this would turn into ax plus b over x squared plus 4 plus cx plus d over x squared plus 9. Now multiply by the common denominator, and you're going to get x plus 1 is equal to ax plus b times x squared plus 9 plus cx plus d times x squared plus 4. Now what do you use? Because this is not factorable, this is not factorable, and this is not factorable. So what can you do now that you can actually do something? What can you do?
FOIL.
Okay, I heard somebody say something. Say it again. Skype people.
FOIL.
Did y'all understand that?
I think he said foil.
Foil. I wanted him to say that. It's F-O-I-L. I don't say it. F-O-I-L. And you get x plus 1 is equal to ax cubed plus, however you want to write it, a 9x or 9ax, whatever, plus bx squared plus 9b plus cx cubed. Y'all check my algebra because this can get kind of tedious. Plus 4cx plus bx squared plus 4b. X plus 1 is equal to, let's combine our terms, a x cubed plus cx cubed plus bx squared plus dx squared plus 9ax, oh, let's see, yeah, plus 9ax plus 4cx plus 9b plus 4d. Now, the reason I'm going through all this is because I'm showing you what the outcome is. Right here, watch. X plus 1 is equal to what? A plus C x cubed. And then that's going to work all the way down. Plus B plus D times what? X squared. Good. Plus what? Nine A plus what? 4C times what? There you go. Plus 9B plus 4D. Now, I'm not going to go on because this is, we're not, the only reason I wanted to do this to show you, now you have 1x to the first plus 1x to the 0. And now that 1x is going to be equal to this guy right here. So you can say 1 is equal to 9a plus what? 4c. I'm going to take my highlighter and I'm going to highlight that. 1 is equal to this because of the x. Equal coefficients. And what else can I say? Well, where's my x to the 0? Here's my x to the 0 right here. Technically. So you could say 9b plus 4d is equal to what? 1. But it's not, I didn't do this one to solve it. I did it to show you what to do when you had quadratics. And you change your a to that. And instead of d, you're going to use that. And c would be what? Instead of c, you would use dx plus f. That's right, class. And d would be whatever comes after f. Gx plus h or fgh, whatever. Dang old alphabet. What you say? Okay, somebody tell me, you remember this? Any? Okay, well, be glad that I took the time to go over it with you.
Well, thank you.
What?
Thank you.
I don't know why I can't hear him. Who is that? Is it off again? Hold on. Hold on. There we go. Okay, now say it. What'd you say?
Thank you.
Oh, you're welcome. Is that Mr. Hutt?
Yes,
Doesn't he
sir.
sound like he's in a barrel? He's probably drunk. He probably just woke up.
I wish I was drunk.
As Bill Murray says in Groundhog Day. Have you ever seen Groundhog Day? Great.
Drunk every day.
No, I don't like the black-headed girl. I don't like her. But anyway, I think Sandra Bullock would have been a whole lot better. But I think Sandra Bullock should be in everything. Anyway, the whole point is, he said, being drunk is more fun. So. All right, so now you ready to apply this? Yes, Hubert. Good, class. All right, now since I've taught y'all so well, you should be able to do this now. 5 over x squared minus x minus 6 dx. See you, Mr. Edwards. Watch for the homework. No, that was Annabelle. That was a scary ass movie. Annabelle and I can't remember the name of that movie. Was Mama or Mother? Mama? Whenever somebody opens this door, it makes that door open. The door will close there. That's where that's coming from. I told you it was Annabelle. Okay, Skype people, how you coming? Let them quit. So, what am I going to do with the bottom first? Factor it, because it's factorable. How do you know that? Well, You've seen it before. That's why. So I'm just going to forget the integral right now. I'm just going back to algebra. So 5 over x, reverse FOIL, x, and we're going to have to use that 2 and that 3 because 1 and 5 won't give you a 1. So we're going to put a 2 there and a 3 there. We got to have a negative, so that means 3 has to be negative, unlike sign, so that's positive. So that's going to be equal to a over x plus 2 plus b over x minus 3. I don't know why I'm making notes. I don't follow them. 5 is equal to what? A times, nope, x minus 3. It's always the opposite. Plus b over what? Now there's 2 ways to solve it. The easiest way to solve it, since they're all linear, since they're all x to the first, the easiest way to solve it is the 0 factor. So what will make this a go away? The 0 right here, but what would make the 0 there? I'm sorry, what? Positive 3. So 5, I'm going to say x is equal to 3, and I'm going to say 5 is equal to a times 3 minus 3 plus b times 3 plus 2. Good, it's going to come out nice. And then what happens to the a factor? It goes out. And you get 5 is equal to b times what? So b is equal to what? 1. So you got that, write that down. Now find b. I'm sorry, a. Yes, ma'am. Because addition is community. Yeah, it doesn't matter. The only reason I put the 2 first is reading left to right, 2 comes first. But the signs have to be the same. As long as you got x minus 3 and x plus 2, or x minus 3 times x plus 2, or x plus 2 times x minus 3, it's fine. But if you have x minus 2, x plus 3, that's wrong because that won't give you the denominator at the top. Okay, so what do you have to plug in to get a, or to get b to go away? You have to plug in negative 2. So I'm going to erase this. And I'm going to plug in negative 2. X is equal to negative 2. So that's 5 is equal to a times x. I'm sorry. Negative a negative 2 minus 3 plus b times negative 2 plus 2. And of course, the b goes out, and you get 5 is equal to a times negative 5, and a is equal to what? Negative 1. So, you've got b is equal to 1, and a is equal to negative 1. So what do you do with a and b now? Plug it in right here. Yeah, come on. A is negative 1, and B is 1, and now you bring down your and now, well, you don't do this because this is that. So now do those. And I'll erase that. And what is that? Well, if u is equal to x plus 2, du is equal to what? dx. So we've got du over what? Well, we got to add a negative here. Well, you got 1 dx, but a negative, so that means you got a negative out front. Okay? So that's going to be negative natural log of x plus 2. Oops. Plus natural log of what? X minus 3. All right, now look at it and see if you have any questions. Now you see why you need to know partial fractions, because you can't do that any other way. Questions, questions, questions. I hope y'all know we're talking Thursday. I don't like this. Antiderivative, I'm going to start on another piece of paper. 3x squared minus 7x minus 2 over x cubed minus x dx. What's the first thing you need to do? Back out a common term. So I'm just going to pull the thing out. I'll put the integral and the dx on it when I get finished. So that's going to be 3x squared minus 7x minus 2 over x times x minus what? X squared minus what? Up, what do we got? Shortcut number what? Number 3, Hubert. That's right, class. Okay, now you can break it up. You got 3 linear factors. That means A, B, and C. Now what? Don't know FOIL method, distribute.
Hubert, I'm thinking we got this pretty well.
So what is that supposed to mean? Hello?
Yes, sir.
What is that supposed to mean?
I'm just saying that we learned this already back in Calc 1 or Algebra
Calc
1 or
students
something.
have, yes. My Calc 1 students have, but see, class has got some that don't remember it.
Yeah.
So make sure everybody knows it before we move to quadratics, which is next.
I don't remember this.
I'm sorry, what?
I don't remember this.
Oh, Mr. Huff, you were drunk. What? I don't know. Did we go over this last semester?
I don't remember that far back.
I kind of remember it.
I kind of remember it.
I mean, this is algebra,
I know.
guys. I mean,
But what are we doing right here, Faith?
yep.
What are we doing there? We're doing calculus, but 90% of calculus is algebra.
Right.
All right, so 3x squared minus 7x minus 2 is equal to a times what? Well, that's x squared minus 1 plus b x squared, well, I'm going to put x squared minus what? X plus cx times x plus 1. And that's going to be 3x squared minus 7x minus 2 is equal to ax squared minus a plus bx squared minus bx plus cx squared plus cx. Now, the long way would be to get all your common terms and to use solving systems of equations. But what could you do right here? What could you do? Somebody speak up. Okay. We must not have covered it enough because nobody's answering the question. Waiting.
I'll just go get a bottle.
Just go get a bottle? Okay. Which one can we make go away? All right, I don't hear anybody. Somebody tell me which one can we make go away?
The one without an exponent.
Yes, that's true. That's one of them. You can make two of them go away. Mr. Huff named one of them. X is equal to what? -1. What's the other one? One. X is equal to 1 and x is equal to -1. And you can get rid of the A term and the C term. To do that. Make sure you got B and C, or B and C is what you get with the zero factor. And then A you get with plugging in x is equal to 0. Because what can we do right here? If we want to get rid of these two, can I put a 0 right here? And wouldn't that take out those two terms? So your three numbers that you're going to use to zero out, x is equal to 0, x is equal to +1, and x is equal to -1. And that's going to give you, now that we've done all the algebra, what do? You bring down the antiderivative, and then you break up what? And take those derivatives. Well, what's it going to be? Well, 2 natural log of what? x plus or minus 3 natural log of what? Plus what? Natural log of x minus 1. Now, all of these, with these two examples we just did, the functions are what? The factors are all what? Linear. Well, sometimes they're not going to be linear. Sometimes they're going to be quadratic, and that's going to leave you with something quadratic over here with the natural log. I mean, not with the natural log, but down here, or sometimes it may be a square root. And what happens when it's a square root? What do we just get finished covering? Trig what? Substitution. So you see where this is going? Okay, we're crawling right now. By Thursday, you're going to be walking and running. You're going to be doing major integration with complicated algebra. Okay, so let's do a nerd. I wanted to do a quadratic. There we go. Do something simple. Somebody tell me what time it is. Okay, I got 8 minutes. Antiderivative of x squared minus 1 over x times x squared plus 1. Now, right quick, you need to write down what this would look like on a test. It would look like x squared minus 1 over what? X cubed plus x. Okay, now go back to the first page of notes. And what do you do if you have a quadratic? You've got to write that quadratic with not b, but bx plus what? C. Because what is this one? That's a linear factor. So we're going to write it as a over x plus what? Bx plus c over x squared plus 1. All right, now go to it. Faith. You there, Faith? She's not there. You get the roll while y'all are working on this. Okay. Mr. Huth, are you good on the natural logs now?
I am.
Okay. All right. We'll go to the I better do my darn online. This is stupid. Oh, we didn't have week 11, so I don't have to do that. Okay, good. 141. Okay, Ahmed is Skyping in. Faith is Skyping in. Bradshaw is Skyping in. Edwards is here. Grant's here. Hutt's Skyping in. Khalil is not here. Nabay is here. Patel is here. Pierce Skyped in. Scobie Skyped in. Sheik is here. Silver's here. Thompson.
I'm here.
Okay, sorry. You were the first one I added. Tucker is here. Wisenhunt is here, and Williams is here. So only one person absent today. All righty. What was that noise? Was that Annabelle in the computer? Well, nobody's going to talk to me anyway. I don't know why I'm asking. So, what do? You get x squared minus 1 is equal to a times what? That's a train. Now what? Well, you could try, you can say x is equal to 0. Why? Right there. And what would that do to this term? It would knock it out, but it's not going to do you any good because, well, it may. I'm going to go ahead and distribute it. You could try that, but I'm going to just go ahead and distribute it because there's too many what? There's too many variables. You see what I'm saying? In the previous problem, there was a lot of numbers and variables. Here, we just got a lot of variables. So you might want to go ahead and distribute it. So x squared minus 1. I've got the rest of going at the same time. I mean, it's not moving and I understand that. Equals ax squared plus a plus bx squared plus cx. Make sure I didn't mess up. Okay? X squared plus 0x minus 1 is equal to a plus b x squared plus cx plus a. Oh my goodness, look at here. Look what we can do. Get 3 highlighters on this one. The 1 that's right here is equal to what? A plus B viewers. That's right, class. What's the 0 equal to? Oops. Well, let's see. Let's take our aqua highlighter. What's the 0 equal to? And what's A equal to? No.
One.
What'd you say?
1.
1. So, 1 is equal to A plus B. C is equal to 0. And A is equal to -1. And what do you do with -1? Plug it in, Hubert. 1 equals -1 plus B. And B is equal to what? 2. All right, plug it in. So A is -1. And bx plus c, b is 2, but c is what? 0, so that's going to be 2x. Uh-oh, we got something a little bit different up here. Not much, but just a little bit. So now we can erase all the algebra, now that we're done with the algebra. And then, of course, it gives us that small. Why they can't make the eraser bigger? I don't understand that. You can, it's bigger. I've said, look, see? See it right there? That's how big it's supposed to be. No, and the second one doesn't do anything. See? Okay. So, derivative there, dx, I'm sorry, antiderivative. So, -1 dx over x plus, you could factor the 2 out, but don't, because there we go. And what is u? U is equal to x. Du is equal to what? This one looks a little bit different, but it's still the same. U is equal to what? Du is equal to what? 2x what? So we still have it, but I'm trying to kind of get you ready. You're going to start seeing different stuff than this. You're going to start seeing more complicated antiderivatives. So I'm kind of letting you crawl before you walk. So negative natural log of x plus natural log. Natural log of what? X squared plus 1 plus c. I'm going to put some more, we're going to go over some more problems Thursday, and they're going to look a little bit different, but they'll be a whole lot more challenging. But I'm going to put some problems up this morning and let y'all get used to them, okay? Y'all have a good day, and see y'all Thursday. Skype people, y'all have a good day.
You too.
Try to keep between the ditches. Who's Annabelle? Hey, Annabelle. What happened to your voice? You don't have what I was saying, Annabelle.
I got it back now.
Okay, I was saying that seems old to you because you had an exceptional algebra teacher, an exceptional trig teacher, and an exceptional Calc 1 teacher. So that's why you're kind of not challenged right now. Don't worry, Thursday's coming.
Oh yeah, yeah. The homework was pretty challenging. I'll say that.
Yeah, you talking about trig substitution?
There was on the I'd have to look back at it, but it was the second to the last one on the one with 17 problems.
Uh-huh.
And it was like